We want to find the derivative using logarithmic differentiation. Logarithmic differentiation is a really nice technique when your expression that you're trying to calculate the derivative of is really complicated. In this example, we have a product and a quotient, and within some of these factors, you would have to use the chain rule. So calculating the derivative might get a little bit messy. So logarithmic differentiation introduces logs into your equation, and then when you introduce the logs, then you're going to use implicit differentiation to calculate the derivative. So I'm going to introduce the logs on both sides of the equation. And what this does is it allows you to use your algebra properties of logarithms, your product rule for logs, your quotient rule for logs, and your power rule for logs to simplify the expression on the right. So I'm going to do a little bit of algebra using those log properties. So using the product rule for logs and the quotient rule for logarithms, I can write this as natural log of x plus 2 squared plus natural log of 2x minus 3 cubed minus, I'm putting a minus because this last factor is in the denominator, natural log of 3x minus 5 to the 4th. I'm going to do one more step with algebra using the power rule for logarithms. Each one of these expressions has a power, so I'm going to use the power rule for logarithms to turn that power into a coefficient on the log. So that becomes 2 natural log of x plus 2 plus 3 natural log of 2x minus 3 minus 4 natural log of 3x minus 5. So now I've rewritten this expression. It no longer has a product or a quotient, so calculating the derivative will go a whole lot smoother. But because we introduced the logs into the equation, our equation is no longer in explicit form. It's in implicit form. So we're going to have to calculate the derivative using implicit differentiation. So I'm going to take the derivative with respect to x on the left and take the derivative with respect to x on the right. So on the left, our variables don't match. So because they don't match, we're going to have to use the chain rule. And we're also using the derivative rule for natural log. The derivative rule for natural log is the inside derivative over the inside. So that's the derivative of the inside over the inside. And we're going to do the same thing on the right-hand side. However, on the right-hand side, the variables do match. So we're going to actually be able to calculate those derivatives. So I'll carry down that 2 as a constant multiple. I'm going to use the rule for derivative of logarithms. That's the derivative of the inside over the inside. So we get the derivative of x plus 2 to be 1 over the inside of x plus 2. Then I have a constant multiple of 3, which I'll carry down. We've got a natural log, so I'm using the rule of the derivative of the inside over the inside. So the derivative of 2x minus 3 is 2 over the inside of 2x minus 3. Carry down that constant multiple of minus 4. and I'll multiply by the derivative of the inside. The derivative of 3x minus 5 is 3 over the inside of 3x minus 5. And we now have y prime over y equals 2 over x plus 2 plus 6 over 2x minus 3 minus 12 over 3x minus 5. My goal was to calculate the derivative of y. So I'm going to solve for y prime by multiplying by y on both sides. And y prime is on the left because those y's cancel. And I have y times 2 over x plus 2 plus 6 over 2x minus 3 minus 12 over 3x minus 5. And the last thing I'm going to do here, at least in the derivative calculation, is that I don't want to write my answer in this way because I've got y's and x's. I would really just like x's in my equation. So the original problem gave me the value of y in terms of x's. So I'm going to substitute that in for y. And that's x plus 2 squared times 2x minus 3 cubed over 3x minus 5 to the 4th. So I substituted that in for y, and then I'm copying down this right here. So this gives me the derivative of y with only values of x, and this is an acceptable answer, but I will do a little bit of algebra cleanup for you guys to show you that you can get to a simpler answer here, and you're going to see some canceling will happen. So I have x plus 2 squared times 2x minus 3 cubed over 3x minus 5 to the 4th. And in this parenthesis on the right, I'm going to get a common denominator. So when you get a common denominator, you're going to have x plus 2 times 2x minus 3 times 3x minus 5. So this term here only has the x plus 2, so I need the two missing ones over here. That's 2 times 2x minus 3 times 3x minus 5. This one has 2x minus 3, so I need x plus 2 and 3x minus 5. That's plus 6 times x plus 2 times 3x minus 5. And then that last one would be missing these two here. It's minus 12 times x plus 2 times 2x minus 3. So what's going to happen, the reason why I've done this, I still have to simplify. I haven't done any simplification on this whole big thing here, but I wanted to show you why I was doing it. And the reason why I was doing it is because this x plus 2 would cancel with this x plus 2, just one of them. This 2x minus 3 would cancel with one of those, leaving me with 2. And this 3x minus 5, it wouldn't cancel, it would combine with that one to be 3x minus 5 to the 5th. So that becomes x plus 2 times 2x minus 3 squared over 3x minus 5 to the 5th. And now I just have to simplify all that algebra on the right. A bunch of multiplying out and combining like terms. So this would give me 2 times 6x squared minus 10x minus 9x plus 15 plus 6 times 3x squared minus 5x plus 6x minus 10 and minus 12 times 2x cubed minus 3x squared plus 4x minus 6. So I've got 2 times 6x squared minus 19x plus 15 plus 6 times 3x squared plus x minus 10 minus 12 times, I think I wrote this wrong over here, that should be 2x squared, and this would be 3x. That's 2x squared plus x minus 6. I have a little bit more distributing to do to get 12x squared minus 38x plus 30 plus 18x squared plus 6x minus 60 minus 24x squared minus 12x plus 72. And now we can combine like terms. So we have 12x squared, 18x squared, minus 24x squared. So 12x plus 18x would be 30x. And then we're going to subtract 24 to get 6x squared. And then we have negative 38x, positive 6x, minus 12x. We've got negative 38 plus 6 minus 12 gives me negative 44. 30, 60, and 72. 30 minus 60 plus 72 would give me 42. And then I could write this as x plus 2 times 2x minus 3 squared over 3x minus 5 and 6x squared minus 44x plus 42. Now go ahead and stop there, even though I can see a little bit more. These are all even, so you could factor out something there as well. Thank you for checking out my videos. Have a great day.